sine and cosine and tangent, actually, we're going to do the next one. So if the equation is y equals sine theta and theta is my x-axis, we're going to plug in a bunch of x's to get our y. So 0 goes in for theta. What's sine of 0? What's sine of 0? 0. Okay. Sine of pi over 6. Sine of pi over 6. 1 over 2, yes. Sine of pi over 2. Everything's defined in a sine. Stop it. Pi over 2 is the 90 degree. What's the y? It's 1. 5 pi over 6. One over 2, I heard, yes. Sine of pi. 0. Sine of 7 pi over 6. Negative 1/2, yes. Sine of 3 pi over 2. Negative 1. Sine of 11 pi over 6. Negative 1/2, yeah. Sine of 2 pi. Okay, so let's plot this now. If you can't read these little things here, this is pi over 6, pi over 4, pi over 3. Like that's the ticks in the unit circle. So 0, 0 would be here. Okay, pi over 6.5 would be here. Pi over 2 would be at 1. 5 pi over 6 would be this one here that's close to pi, so that's 1/2, and then 0. And we have negative 1/2 right there. And then at 3 pi over 2 is negative 1. Then at 11 pi over 2 is negative 1/2. And then right there. So it kind of looks like what? A sine wave. Okay, so if we actually connect the dots, the reason why I use this graph is not because it's necessarily a nice scale. If you see the values between and you just start connecting it like this, you can actually see how it's supposed to go. So like that. So do you see how it's actually, it's one continuous wave, and we can continue that way, yeah? So let's grab our graphing calculator and look at what this looks like. You have to put your mode in radians. If I wanted to continue, so it was exact on this side, then the way I would say to do this is now, just remember key points, and then you know they have to kind of connect. So for instance, at negative pi over 2, that's going to the 270 negatively, right? That's negative 1, then it's at 0, then it's at positive 1, then it's at 0. So you see it'll continue like that, right? So like I said, once you know what it looks like, you're going to use those key points, and you'll know that it goes through 0, 0, it goes up to 1, then it goes back to 0, goes to negative 1, and then back to 0. Okay, so let's look at some key features here. Amplitude. Some of you that took physics probably know a lot of these terms already. Amplitude is the distance from the axis to the peak or the valley. The axis is also called the median, and sometimes this shifts up and down based on transformations. So what is the distance from the axis to the peak or the axis to the valley? I think in physics you call this crests and troughs, right? So what is that? 1. What's the period? The period is the length of the shortest interval after which the graph repeats itself. So if we're to say look at 0, 0, how long does it take until it starts that wave again? 2 pi. What's the domain of this function? Yeah, it's negative infinity to positive infinity. It goes on forever, x-wise. However, the range, what's the range here? -1 to 1. Does that make sense to you that the range would be limited? This should also make sense, and maybe last year you remember when you did those triangles. In the unit circle, the radius is 1, which is the hypotenuse. The hypotenuse is the biggest side, and because sine has to do with the opposite and the hypotenuse, that means the opposite always has to be smaller than 1, right? So when you have a range, that's why if you try to find inverse sine of 1.2, what would happen? There's no possible solution, right, for it? Or negative 5 point something? You can't, right? So when we get into solving, you'll have to remember that key, that if you ever get a sine ratio that's bigger than 1 or less than -1, it would be a no solution. Okay, what's my y-intercept here? 0. And what's my 0? So if I do it as a list, negative -2 pi, -pi, 0, pi, 2 pi. So what is this? This is our multiples of pi. So I tried explaining how to do this before when we introduced k. So the way we write this is, if k is an element of integers, how would I generate a list of multiples of pi? K pi, yeah, very good. Okay, so that would be my zeros, k pi. Does everybody understand what the list of integers is? The list of integers is, say, ... -3, -2, -1, 0, 1, 2, 3, ... So if I take that list and multiply it by pi, do you see I'll get this list? Yes? Okay. That's a fancy Z for integers. Okay, cosine. Okay, remember cos? Get your hand ready. What's cos of 0? Not 0, 1. And if you're having trouble with the axis, just think about what coordinate it is, right? Cos is your x-coordinate on the unit circle. Okay, pi over 3, cos of pi over 3, 1/2. Cos of pi over 2, 0. Cos of 2 pi over 3, -1/2. Cos of pi, -1. Cos of pi over, 4 pi over 3, -1/2. Cos of 3 pi over 2, 0. Cos of 5 pi over 3, 1/2. And cos of 2 pi, that would be 1 again. So if we plot those, we have 0, 1. We have pi over 3. Remember, these ticks are pi over 6, pi over 4, pi over 3. So that's 1/2 this time. Pi over 2 is 0. 2 pi over 3 would be 1/2. And then pi would be -1. Then 4 pi over 3 would be 1/2 again. Then 0. Then 1/2. Then 1. So then again, the way these, I have the bars here on this graph. If you do all the intersections there, you'll see it's the rest of the wave. So you can see it goes like this. Looks very similar to the sine graph, doesn't it? Yeah? Okay. Okay, so now let's fill in the left of this graph, now that we know that what it looks like. So, and again, the key points would be at the pi over 2's, there's zeros. And at the negative pi would be negative 1. And then this would be positive 1. So then you can see how it all kind of connects, yeah? And never keep on going with your arrows because the domain is what again? All real numbers, yeah, or negative infinity to infinity. I don't have the rest on this page. I guess I have to go. I'm going to do dual so we can do this at the same time here. Where's my dual? There we go. I don't know why it's not showing. Okay, so let's look at this graph here. What's the amplitude? It goes from the axis to the max or the min. So what's my amplitude again? 1. What's my period? Again, it's the length of time it takes before it starts repeating itself again. If we start at 0, do you see we're at a max? When does it become a max again? At 2 pi. The domain, of course, is all real numbers. The range is the same, negative 1 to 1. My y-intercept, this is in the way. Let's put it over there. Oh, it doesn't like going over there. Anyways, my y-intercept, of course, is 1. My zeros. Well, what is it right there? 1, yeah? Okay, so now, what's my zeros? It's negative 3 pi over 2, negative pi over 2, positive pi over 2, positive 3 pi over 2. So I'll go dot, 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 negative pi over 2. Oh, I should have had negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2. What would be the next one after 3 pi over 2? Nope. What would it be? Oh, maybe we don't get what this list is generating. It's doing, yeah, it's 5. It would be 5 pi over 2, then what? No, 7 pi. It's going odd numbers of pi over 2. So how do I write that? I could say it's pi over 2 plus 2k pi. Does anybody know what 2k pi would represent? What does 2 pi represent? 1 revolution. So if I have the extra k in there, that would be however many revolutions that you want, right? So if k was 0, then I would have no revolutions. If k was 1, I would have 2 pi, so that would be 1 revolution. If k was 2, that would be 4 pi, so that would be 2 revolutions. I notice I have k as an element of, that says I there. Some books use I and some books use Z. I'm going to put Z. Why am I going to put Z? Because that is the real symbol for integers. Yes. So in the transformation unit, we saw the form y equals a f of x related to y equals f of x by a what stretch factor of what? A vertical stretch factor of a. If a was less than 0, then the reflection is reflected in the which axis? The x-axis. Very good. Guess what's associated with the vertical stretch, or a? The amplitude is equal to the absolute value of a. So we're going to get our graphing calculator, and we are going to graph the following. We're going to do cosine first, and then we're going to compare it to 3 cosine. But before we do that, I'm going to pause it so I can get my... Now it's not working. So how does this change on my graph? I'm going to do a different color. I'm going to do green maybe. It's now going to be at 3. So 3 0 is still the same. -3, 0, +3. And then make sure you do kind of like a little false swoop. Like don't do, the biggest mistake people make is make it with a ruler. Do not use a ruler. This is the first time I'm saying don't use a ruler. It should be nice curves. Do you see? So, and make sure you put arrows at the end or that will be a half mark deduction. Y equals 3 cos theta. Of course, the blue one is y equals cos theta. So you can see visually the difference between the two. So let's fill in this chart. Cos theta, the amplitude was 1, the period was 2 pi. The zeros were every, what were they? The odd intervals of pi over 2. So that would be pi over 2 plus k pi and 3 pi over 2 plus k pi, where k is an element of integers. My y-intercept was 1, my min was -1, and my max was +1. Yes? Okay, so now the amplitude is affecting the vertical stretch, or the vertical stretch is affecting the amplitude. Do you see the amplitude is now 3 times the height? Yes? Does it affect the period? Period is how long this is. Does a vertical stretch affect the length of the period? No, so it's still going to be 2 pi. So that means my zeros are going to be the same. Yes? My y-intercept, again, does it make sense that if it's a vertical stretch, it would affect my y-intercept? It's now at 3. And again, the min and the max are your y values. So if it's a vertical stretch, hopefully it makes sense to you that that would affect that as well. Yes? Okay, so let's now graph 1/2 cos x and on the same. Okay, so I'm going to graph it on here. Does everybody see, based on my graphing calculator, and it should make sense to you. The 1/2, again, is your vertical stretch, but it's now halving all the y values. So instead of at 1, it's at 1/2. It's still at 0, but then it's at -1/2. Everybody see what's happening here? So this was actually harder to graph because it's less... Okay, we got an arrow, y equals 1/2 cos theta. What happened to my amplitude here? It's half, right? Again, look at the distance from the axis to the top. That's 1/2. My period didn't change. Again, that should make sense. It's a vertical stretch. My zeros are the same. My y-intercept is now half the amount, right? My min is half the amount, and my max is half the amount. So what do you think is going to happen if I stick a negative there? Does everybody know with the graphing calculator that you have to use negative and not okay, so 1 becomes -1. The zeros are still the same. -1 becomes +1. So we continue over here. Okay, so then this is y equals negative cos x. Okay, so then how does that affect my amplitude? Is the amplitude now -1? No, amplitude is the length. The length is always positive, which is why I said it's the absolute value of whatever your A is. So it's still 1. Your period is still 2 pi. The zeros are still the same. My y-intercept now is not the same, though. What is it? -1. But my min and my max, although they've switched positions, they're still the same, right? -1 and +1. Because the min became the max and the max became the min, but they're still the same values, right? Okay, does everybody understand this? So I guess the key here is, does everybody see the number in front is your amplitude? Absolute value of A is the amplitude. So on a multiple choice, you wouldn't be graphing these to figure it out. You should just be able to look at the A and tell me what the amplitude is, right? Okay, moving on. From the transformations unit, we saw that a function in the form of y equals f of bx is related to y equals f of x by a horizontal stretch factor what? 1 over b, yeah, 1 over b. If b is less than 0, then the function is reflected over the y-axis. The period, remember the period was the length it takes before it recycles itself? The period of the sinusoidal in the form of y equals f of bx is equal to, now if you notice, the sine and the cosine both have a period of 2 pi. So what do you think is going to happen if I take that b and do something to it? I'm sorry? It'll get bigger and smaller. So what would the b, like would it be b times 2 pi? For instance, I'll give you an example. If this was f of 2x and my normal period is 2 pi, what would my new period be? 1 pi, right? I'll change this to a 3. If my normal period is 2 pi and now it's f of 3x, what would my new period be? 2 pi over 3, yeah. So guess what it's equal to? 2 pi divided by whatever your b is. Yes. Okay, and it's absolute value because, again, the period is a length. So it doesn't matter if b is positive or negative. It's still going to be positive. Okay, so here is my sine graph. We're going to do the same thing on a graphing calculator. We're going to graph y equals sine theta and y equals sine of 2 theta. Okay, so let's graph it on here. I'll use green for the first one. So basically what's happening here is, does anybody remember what this was? Pi over 2. So it's taking, instead of at pi over 2 getting a height of 1, it's half the amount of time it's getting a pi over 4, it's at 1. Right here where it's at a 0, it's getting halved. You see it's getting squished. This one's at 3 pi over 2, so it'll now be half, which is, what's half of 3 pi over 2? 3 pi over 4. So that would be, say, there. And then, that was that one, right? So 2 pi now becomes pi. So 0 is still 0. Does everybody see? It got squished. I could go more. This is 3 pi becomes 1.5 pi. So, and continue it. That's probably good enough because this is going to be too squished in a second. So this is y equals sine of 2 theta. And then this one over here is y equals sine of theta. So if I go back up here, remembering that my amplitude was 1, my period was 2 pi, my zeros were 0 pi, 2 pi, that was k pi, where k is an element of integers. My y-intercept was 0, my min was -1, and my max was +1. So how does that change for my sine of 2 theta? Does that affect my amplitude? No, a horizontal will not affect a vertical. Amplitude is vertical. So it's still going to be the same. And look visually, it's still the same, right? It does affect my period, right? So instead of 2 pi, it's getting halved. So now it's at pi. Does everybody see visually it took pi to complete that cycle? So if it's cutting my x's in half, what would happen to my zeros? It would be 0, pi over 2, pi, 3 pi over 2. It's every pi over 2. So that would be k pi over 2. Oops. Okay, my y-intercept still 0 because that didn't get affected, and my min and max didn't get affected. Okay, so let's now take our graphing calculator and graph y equals sine of a half theta. Okay, so anyways, y equals sine of a half. It does not affect the amplitude. But what happened to the period? It got doubled, so now it's 4 pi. And remember the formula for it was 2 pi divided by your b. Your b was a half. Do you see? That gets flipped and multiplied. Do you see how I'm getting 4 pi? What's going to happen to my zeros? Oh, maybe we should graph this just to make it easier. So my 0 stays as 0, but this 0 over here gets doubled. Do you see that? And then the height of 1 gets doubled, and that was at pi over 2, so now it's at pi. So you can see it's going like that, right? And then this gets doubled, so now it's at, well, that's there, so this is going to be here. Where's my negative? Right there. Yeah? So that's y equals sine of a half theta. Okay. So anyways, it's now 0, 2 pi, 4 pi. 0, 2 pi, 4 pi. How could I create a list? It's multiples of 2 pi, right? So that would be 2k pi. But again, all you're doing is doubling what it was before. Yeah? My y-intercept is, oh, I should put an arrow here. My y-intercept's still 0, and my min and my max are still the same because that didn't get affected. So I'm going to quickly do the reflection. Again, go on your graphing calculator and change. Sine theta is an odd function because a mirror in the x is the same as a mirror in the y. So we'll do it that way, where the height of pi over 2 at 1 becomes over here. And actually, it might be easier to do it as a, right? Okay, so I'm going to make mine thinner because I don't like it. Y equals sine of negative theta. Okay, so amplitude still is the same. The period's still the same. It just got reflected. The zeros are still the same. Everything's all the same. Yes? All right. Good? So now we're going to go into, oh, hopefully we can do this quickly. Tan is very cool. Tan is very cool. Okay, what's tan of 0? Tan of 0. 0. Remember, tan is undefined at the y-axis and zeros at the x-axis. Tan of pi over 4. 1. Tan of pi over 2. Undefined. Tan of 3 pi over 4. Negative 1. Tan of pi. 0, yes. Tan of 5 pi over 4. 1, positive 1. Tan of 3 pi over 2. Undefined. Tan of 7 pi over 4. Negative 1. Tan of 2 pi. 0. 1? Okay, let's go to our graphing calculator and graph tan just for fun. I'm having so much troubles. How do I draw on a graph undefined? I don't know if you guys have ever seen this before. What?